Hello viewers, and welcome to the lesson Matrices and Transformation. The question is here: the vertices of triangle PQR are P -3 2, Q 0 -1 and R 2 -1. A transformation matrix maps triangle PQR onto triangle P', Q', R', whose vertices are P', -7 2, Q', 2 -1 and R', 4 -1. Find the inverse of M, the transformation that maps P', Q', R' onto PQR. So that is the question. Let us go to the solution. So the first thing you're going to do is to let the transformation that maps triangle PQR onto P', Q', R' be represented by ABCD. So when you are transforming object using a transformation matrix, we do pre-multiply. So what you're going to do, we shall take this matrix of transformation ABCD, and then we pre-multiply that one with the object that is a PQR. So we give the coordinates of PQR, which are -3 2, and we have another one 0 -1, and we have 2 -1. This one is equals to P', Q', R', and you're given these. You can insert this one as well. P' -7 2, and then 2 -1, R 4 -1. So that is the first thing you're going to do. So from there we can pre-multiply. It's my hope that you know how to multiply these multiplication of matrices. So we're going to take this row 1 multiplied by column 1. You don't need to take all of them to get the values of A, B, and C, and D. So row 1, column 1, this row where we have AB multiplied by this column where we have -3 2. So this will be A times -3. This will give -3A, then plus B times 2, we get 2B. That one should give me this value here, -7. And then I now take row 1, column 2. So A multiplied by 0, we get 0. Then plus B multiplied by -1, you get -B, and this one should give 2. Now with these two, we'll be able to solve this simultaneous equation. You can see the second equation here. Already -B is equals to 2. So according to that, B will be -2. So we just need to substitute in the first equation here, -3A plus 2B, and B is -2, so that one will be -4 is equals to -7. So when you work out these, 3A minus 4 is equals to -7, you will get A as, so get -3A is equals to -3, and therefore A will be 1. You get A as 1. So you can see now we have the value of B and we have the value of A. Now we can proceed and get now C and D. Now for C, we are going to take row 2 multiplied by column 1, row 2 multiplied by column 1. So C times 3, you get -3C. So this is -3C. And then plus 2D, D times 2, plus 2D. This one should give me 2. Here should give me 2. So this one should give 2. Then row 2, column 2, C times 0, we get 0. And then we have D times -1, we get -D. And this one should give what you have here, -1. Already here, using this equation here, we shall have D as 1. Substituting in the first equation, -3C, where D is 1, so you get plus 2 is equals to 2. So negative 3c is equals to 0. So c is equals to 0 and d is there. Now from these you can see now we have the values of a, b, c and d. So a is 1, so we can write the matrix. So therefore a, b, c, d, which is the matrix of transformation, would be given by a is 1, then b is negative 2, then c is here, c is 0, and d is 1. So that is the matrix that transforms or that maps PQR to P prime Q prime R prime. We've got to read this. So that is the matrix. Now, having obtained that, we can now get the inverse. Find the inverse of M, the transformation that maps something here, P prime Q prime onto PQR. So we are supposed now to find the matrix of transformation that will map P prime Q prime R prime onto PQR. Now what we have is the matrix that transforms PQR onto P prime Q prime R prime. So, and this one we've got, this one is 1, negative 2, 1, negative 2, 0, 1, like that. So the first one, this one means that we should get the inverse. We are getting the inverse. So to do this, we shall simply get the inverse of this matrix that is here. The matrix that is going to map P prime Q prime R prime onto PQR is the inverse of this matrix 1, negative 2, 0, 1. It is the inverse. It is doing the inverse. So we just need to get the inverse. So M inverse, how do you get the inverse? Just to remind you, if you have, this is just a recall, if you have any matrix A, B, C, D, the inverse is obtained by 1 over the determinant. The determinant is given by AD minus BC, then D negative B, D negative B, then negative CA. It's supposed to be like that. So given any general matrix ABCD, given any general matrix ABCD, when you're getting the inverse, you first get 1 divided by the determinant. The determinant is AD, subtract BC. Then this is how we touch these values. So D will be there, negative B, then negative CA. So you can see what is happening here. Now you can see what is happening this diagonal, AD, DA. The values, the elements are being interchanged, and in the other diagonal, they change the sign. So according to this matrix, 1, negative 2, 0, 1, get the determinant, 1 times 1, subtract negative 2 times 0, you get 1. So the determinant is 1. So 1 over the determinant, which is 1, then interchange. So for this diagonal, AD, DA, they're being interchanged. So that one remain to be 1, 1. And then the other diagonal, look at what is happening. BC, negative BC, they change the signs. So negative 2 will be positive 2, 0 will remain to be the same. So therefore, the inverse, which is now, this is the inverse of M, will be given by this matrix, which is 1, 2, 0, 1. So that is simply how you are supposed to solve that question.